This is Ed Robinson of Kensington College, continuing our lessons on C#. Today we'll be talking about strings. A string is a piece of text. Let's see how we make a string in C#. We first of all use the string type to say that the variable st1 is going to be allocated these characters. This string here is indeed a class. We are creating an object of st1. We'll come back to that in a moment. But this object, this class, can also be capitalized, and that means exactly the same thing. If we wish to print out our string, we can make a right line, so I'll just do CW tab, and then st1 is what I'm going to print out to the console, and then I can run that. And you'll see indeed that my house is output to the console. It might be useful to see that string object in memory. So I'll put a breakpoint here and run down to that line, and then you can see at the moment that the st1 is null. If I single step F11, then you see that I've opened a watch window here, and I've put the ampersand st1 here, which gives me the address of the string. Well, not quite the string. Let's find out what is indeed there. As you can see, I have two memory windows open, and I take note of this address here, 39DEF0, which I'm going to type in here into the first memory window. Now, when I press that, I expected to find my string, but no, it's not. There's another address here. So if I type that address into my second memory window, rather like a treasure hunt looking for our string, then if I press enter, you can see that the object is located at this address. Notice that I put that address in backwards. This is 02, etc. You see I've typed this in backwards, and there's my object. Now you can see the object is here, and the string HOUSE is just located a bit further down, so just emphasizing that this thing is indeed an object, and the object contains the string of characters, an array of characters. So once again, this emphasizes what a reference type is, which is what a string is. You see here we have the first address, that's the reference to, and this is in the stack, by the way, the stack memory. It's a reference to the actual object itself, which lies on the heap. If we wish to access the individual elements, we use the square bracket, much like an array. So we could say that a string is an array of characters, roughly speaking. So we're taking the first element. So which element is that going to print out? It's going to print out the very first element, which is the H, 0-based. But you might try this. If you were to try and poke a bit of information into here, for example, you might want to poke another character, immediately it complains. We are not allowed to change the individual characters in a string by using this bracket operator. There is another class called the string builder class if we wish to do things like that, but you might find that a bit strange for the moment. But you can't actually directly poke elements into an individual string. Let's find the length of this string. So we could try this, and you can see that appears, so we can find the length of that string. We should write that out. It should give us the result of 5. Which indeed it does. So the length of that string is 5 characters. Incidentally, there's no terminating byte, which you'll find in C++. Let's talk about some methods of the string class. Let's say we wanted to find the position of that u in the string. This is how we would go about it. We could use an integer to find the index of the u in that string. Now, as you can see, that should be position 3. So if I were to print that out, if I run that, I should find that gives me position 3. Position 2, position 2, because it's 0 based. So it starts off at element 0, 1, 2. So u has got the position in the string of 2. We need to be obviously careful of that. So what if you want to extract a bit from the string? Well, we would use the substring. So we want to extract, starting at position, let's say we want to extract these 2 characters here. What is the starting position of this? We need to be careful about that, obviously. Starting position 1, and then after that we're going to extract 2 characters. So that should start here at position 1 and extract those 2 characters. We need to set that equal to perhaps another string, which we'll call, say, st2. And finally we should print out the st2. And when I have run that, you'll find that it gives you the required 2 characters in the string. What do you think the effect of leaving out the number of characters would be? You could have a guess of 2 ways. One, you might say, well, maybe it just returns 1 character, but no, let's find out exactly what it does. So when I run that, it takes all the characters to the end of the string, so it starts at position 1 and takes all of the remaining characters. Let's try and put those concepts together. Let's say we had a string, somebody's name, and we wish to extract the surname. This ought to work for anyone's name, so we have to devise some sort of general strategy. Well, what we could do is first of all find the position of the space, and then we could extract the characters to the right. So let's start off by finding the position of the space. We did this previously using our index of, but what we'd be looking for is the space. So P should return. Now what will it return? It should return that position there, which is indeed position 4. Let's just, don't forget, we're starting here 0, 1, 2, 3, and then that's position 4. So let's we could perhaps confirm that if we were to just run the program down to there, and then we could single step. Well, let's take a look. It says there at the moment that P is 0 because that line hasn't been executed. So now P is 4, so we are indeed on the right track. So to generalize this, we could start at position P, which is position 4 here, and let's see what happens in this case. So if I were to run that, then it looks as if it's worked, but if you look closely, you see that there is indeed a space before the R. What that means is therefore that the substring has looked starting here and found everything from that position. So what we need to do is simply to move it along one position. So let's try that. So if I just increase this by 1, which I'll do here, I might have done it up here, but I'll do it there, and then I can run my program once again, and this time you should see that the string doesn't have that leading space. So a bit of a trick there. You need to increment your index by 1 to find the following string. Let's try some other methods. For example, we want to maybe insert some characters into that string. So if we try this, position number 5, which is here, well, indeed, it's exactly where the R is located, so it should be placed just before the R. You can try that yourself, and you should end up with, notice I've got an extra space here, which is this space here. We could try the replace, where that simply replaces that word with that word, and you should end up with that as a result. We could try the remove, so you could remove some characters using this, so that should produce, we're getting rid of the ACK, which is starting at position number 1 and then removing 3 characters. Finally, we could try the converting them all to uppercase. So if we were to run that, I'll just show you that one. It should produce everything in uppercase, and of course we could use to lower as well. For a full list of these methods, this is a very, very useful reference, which is the Microsoft website. You can see a list of all the methods applying, which we have used some of. We could have an array of strings where we have st1 in this case is an array which contains string Incidentally, make sure you've always included the system namespace. You see, if we didn't have the system namespace, then this would cause an error. So if we wish to access the first string, then the notation is thus. So you're taking the first element So if we run that, you find we get the first string in the array of strings. I've included a read line there to halt my program at that position. We could use the join method to join those two strings together, using that as a separator, so that when we get the result, you'll find that they're concatenated, but I need to print out my st2, of course, and when that's run, you can see they're concatenated without any space in between. If you did want to put a space in there, you could just make that a space. The opposite of the join is the split. First we're going to do the opposite, so we'll start off with a string which has got a space in between, but it's just going to be a string and not an array. So we're doing the opposite. We want to put it into an array. So we have an array of characters, and we're going to use our split upon the string st1, and we're going to split it upon the space character, and then we're going to write out the individual elements of the array. I might as well do both of them. Zero based, of course. So when I run this, we should find that we have our individual array elements, house and individually boat, the elements in an array. So I've split my string into an array. Finally, as an exercise, you might like to try and parse the string. Parse means extract information from this, what is an XML string. I will explain XML later on. For the moment, we're trying to find this bit of data in here, which is at the moment is ed, but it could be anything of any length, so we must make it general. So we need to extract that data, so we need to devise a strategy. So I could leave that for an exercise, but for you, but a strategy might be to find the position of this. So HTML tags always come as a pair, the closing. So you might go and look for this bit of text first, and then this bit of text here, and then work out how you're going to find the text which is in between. I'll give you a clue. When you find the position of this using index of, you'll get the position of this character here. So you might have to adjust that so that that moves along to this character here. Well, it's no secret that you'd use the length of this bit of text, this string, and then that should give you that position there. And once you've got this position here as well, then you could hopefully subtract these two positions and get the number of elements that you need to extract using the substring function. So the first thing we could do is find the position of this string, and indeed this position of that angle bracket, by using this, and using the index of, we're looking for that, and it should turn out to be position 8. Just so it's here, we're starting 0 from here, 1, 2, 3, 4, 5, 6, 7, 8 is this first here. Then we need to find the position of this bit of text in here, and we'll use another variable called pos2 for that, position 2 that is. So if we try that, and that should give us position 19, which is that position there. Now let's indeed run that just to confirm all of that. So if I set my breakpoint, and then I can single step, but you'll notice if I hold my mouse on there, at the moment it's 0, and if I press it, it gives me the position, which you probably can just see, which is position 1, which is 8, and then single step this and find that's position number 19. So we're on the right track. So let's say how we'll actually extract the data. We'll call our variable data, for example, and then we want to find the substring. So we can use our string substring. Now we want to start at the position pos1, but not quite, because there is a problem here that we haven't actually got the position of Joe. We've got the position of this. So how will we move it along to Joe? We need to add something on. Indeed, we need to add on the length of the string. the length of person. Now that's getting a bit untidy. We should really have a variable in here, so we could go back later and make that a variable. But at least that gives us the start position. Well, what that should give us is the length of the string added on should give us 16 altogether, and we could check that out, and if you measure up to here, you'll find that that's position number 16. So we've got this bit right. Now, how indeed are we going to extract the string? Well, we've got the position here, which is 19, and we've got the position here, which is 16. Now 19 subtract 16 gives us 3, which is the required number. So in other words, you need to subtract this pos 1, subtract pos 2, which is what indeed I will do. And finally, we need to read out our data, which has been extracted or parsed from the XML string. And then we could try running that, and indeed show that Joe has been extracted. We could test this program by putting back other data and running it, so it should be perfectly general, and that this time we'll be extracting Ed. So that's how we parse an XML string.